Okay, 5.4 exponential and logarithmic functions. So learning outcomes for today is find the relationship of exponential and logarithmic functions by algebraic and graphical approaches. They compute the composite functions involving exponential and logarithmic functions, and E sketch the graph which involve exponential and logarithmic function on the same axis. Relationship between an exponential and logarithmic functions. First, the inverse of a function exists if and only if the function is one-to-one function. The second one, both graph, which is log and exponential, are reflect on each other about the line y equals to x. Thus, one of is the inverse of other function. So, the third one. And from that, the domain of f equals to range of f inverse, and range of f equals to domain of f inverse. Alright, so from this graph, you can see that let's say we have fx is an exponential function, and the inverse of the f is ln x. And then ln x is a log function, so it's translate at the y equals to x. Alright, example 1. Okay, let's say given fx is ln x, A, find the inverse of x, B, determine the domains and ranges of f and f inverse, hence C, sketch the graph of f and f inverse on the same axis. Alright, A, find f inverse. So we have fx equals to ln x, which is x greater than 0. And then f inverse inside f equals to x, or f inverse x equal to x. And then substitute f inverse into x so that you get ln f inverse x equal to x, and change it into subject. F inverse x equals to e to the power of x. So this is your f inverse. F inverse x equals to ex, which is exponential function. Okay, we have fx equals to ln x. We know that the domain is x greater than 0. So you get 0 to infinity, and range for log function always real. And then the range of f equals to domain f inverse, which is negative infinity, infinity. And then look at the fx equal to f inverse x equal to ex. So the domain f inverse is always real, which is negative infinity, infinity. And range f inverse is 0 to infinity. So from here we can see that domain f equals to range f inverse, and range f equals to domain f inverse. Alright, so we start sketching the graph. So it's up to you whether you want to start with exponential function or a log function. Okay, first, this one is a log function, ln x, and then we have y equals to x, reflection line, y equal to x, and you translate ln x at y equals to x, so you get the exponential function. So y equal to x act as a mirror. And then you see that we have a coordinate for ln x is 1, 0. And for exponential function, we have 0, 1. Example 2, given fx equal to ln 3x plus 2, A, find the inverse of f, B, determine the domain and range of f and its inverse, C, hence sketch the graph of part B on the same axis. Alright, we have a log function and then find its inverse. So we use this definition f of f inverse x equals to x. So use this definition. So we have ln f inverse inside f ln 3 f inverse x plus 2 equals to x, and then we set up f inverse as a subject. So you have 3 f inverse x plus 2. This is a base e to the power of x. So we have f inverse x equals to e x minus 2. And finally here you have ex minus 2 over 3. So this is the inverse of f. Alright, we want to find the domain and range for f and f inverse. So domain for f inverse is always a real number, which is negative infinity, infinity, because this is exponential function. Alright, so to find the range of f inverse is, okay, look at this graph. The function f inverse x equals to, we can written as e power x over 3 minus 2 over 3. So from here we see that the graph is start at 2 negative 2 over 3. Alright, so this is open negative 2 over 3 and infinity. And the domain and range for f, just from here, domain of f inverse is range f, and range f inverse is domain f. Okay, now we are going to sketch the graph f and f inverse on the same axis. Okay, it's up to you, either you want to sketch f or f inverse first. So I would like to sketch this first. Okay, this is exponential function. Alright, so from here you draw x and y axis, and then from here we see that this graph has y negative 2 over 3. So when you have y equals to negative 2 over 3, so you have a line here, y negative 2 over 3 below, and don't forget that the reflection line, this is a compulsory, y equals to x is a reflection line, and then when you have y negative 2 over 3, at the same time you have to draw x negative 2 over 3. Alright, and then look at this graph, exponential. This graph intersect at y, so you have to find what is the value of y. So when at 0, so you have y equals to e power 0 minus 3 2 over 3, get negative 1 over 3. So this f inverse intercept negative 1 over 3 here. So start sketching this graph. So look at this graph, positive, positive. So the shape is like this from here and intercept here, and then never touch negative 2 over 3. So this is your f inverse. And then how to sketch f? And to sketch f inverse, actually you just fold at the line y equals to x. Just fold your paper at y equals to x. Just your paper at y equals to x, and then you get f, the graph of f here. Okay, so Get this graph. Never touch x negative 2 over 3. So you intercept at y negative 2 over 3, and also here is intercept x at negative 1 over 3. So this is the graph for f and f inverse. Example 3, the function f is defined as fx equals to 2 ln x minus 1. And A, state the domain of f. B, show that f inverse exists. C, find f inverse. Lastly, sketch the graph of f and f inverse on the same axis. State the domain of f. So this is the log function. So the domain is x greater than 0, which is 0 to infinity. Okay, show that f inverse exists. So I use algebraic method. So we use fx1 equals to fx2. So we have 2 ln x1 minus 1 equals to 2 ln x2 minus 1. So negative 1 both sides can be cancelled. So you have 2 ln x1, 2 ln x2. So 2 ln x1 equals to ln x2. So x1 equals to x2. So therefore, f is 1 to 1 function. Therefore, f inverse x exists. Okay, find f inverse for C. So we have fx equals to 2 ln x minus 1. So we use f or f inverse x equals to x. Use this definition. So 2 ln x replaced with f inverse minus 1 equals to x. So we have 2 ln f inverse x equals to x plus 1, and divide by 2, x plus 1 divided by 2, change it into index form. So you get e to the power of x plus 1 over 2. So this is the inverse of log function which is exponential function. Okay, they sketch the f and f inverse on the same axis. So I start with f inverse because this is exponential function, so it's more easier. This is we have x positive, y positive, and we find y-intercept at 0, y equals to e 1 over 2. So you get the y-intercept at e to the power 1 over 2. Alright, so draw x and y axis. Okay. So this one. Okay. And then draw y equals to x, reflection line, y equals to x. And then we start with exponential functions, so positive, positive. So the graph from x and y positive, so like this. So intercept at e to the power 1 over 2. So this is your f inverse. So how to find the graph of f? Just fold the line y equals to x, so you get this one. We have y-intercept at e to the power 1 over 2, and we also have x-intercept at e to the power 1 over 2. So this is your fx. Alright, composite and inverse function involving exponential and log functions. Example 4, given that fx equals to 2x plus 1 and gx equals to ex. Function f is a linear, function for g is exponential function. A, find f of g. B, by using graphical method, determine domain and range of g of f. Alright, A we considered as below. So the question asks g of f. So f inside g. So f is a linear function. You put inside g, and the output you get e to the power of 2x plus 1. Alright, so we get the function g of f. We get e to the power of 2 to the power of 2x plus 1, which is exponential function. So from here we can sketch the graph. At 0 you get e to the power of 1, e, and then this is x positive, y positive, so the graph is like this. And after that we can find the domain for g of f, which is real number, and then range of f is 0 to infinity. Alright, example 5. Two functions f and g are defined as follows. F is a log function, g is a linear function. Find g inverse of f and then sketch the graph of part A. Hence, determine the domain and range of the composite function. Alright, to solve for A, g inverse of f. So first you have to find g inverse first. So how to find g inverse? G inverse inside g equals to x. You use the definition and then substitute x with the g inverse. So 3g inverse plus 5 equals to x. After that, let a g inverse as a subject. So you get g inverse of x equals to x minus 5 over 3. Alright, so start to solve g inverse of f. So now we put f inside g inverse. So our f is a log function, ln x minus 2. And then you put into the function of g inverse. So you have ln x minus 2 minus 5 over 3. Alright, so this one can be written as 1 over 3 ln x minus 2 minus 5 over 3. Alright, so we have a previous question. We get g inverse of f is 1 over 3 ln x minus 2 minus 5 over 3. This is a log function. So look at the domain. So the domain is here. This is the domain of function, this function. X minus 2 greater than 0, x greater than 2. So we have x2. And then we have intercept at x, which is when y is 0. So we have 1 over 3 ln x minus 2 minus 5 over 3 equal to 0. So have 1 over 3 ln x minus 2 is 5 over 3. So you get ln x minus 2 equals to 5. And then you have x minus 2 e to the power of 5 as e to the power of f plus 2. So you get the x-intercept at here, e to the power of 5 plus 2. So this is a log function. So we have this one is positive, and then here is positive. So the graph is like this. Alright, so after that, this is the graph. So the domain we can read from the graph, 2 to infinity open, and the range always real. Given m, which is log function, and n is exponential function, find n of m and m of n, which is a composite function. State the relationship between n and m and sketch a graph of both functions on the same axis. Alright, now we put n inside m. Ex minus 2 over 3, and we put inside m. So what happened? 3x we replace with e x minus 2 over 3, and don't forget plus 2. You cancel each other, so ln ex minus 2 plus 2. So this one can be cancel each other. Ln ex, you get x. Alright, for n and n, so we put m inside n. So we have ln 3x plus 2. So now ln 3x plus 2, you put into the function n. So we have e ln 3x plus 2 minus 2 over 3. So here e ln to the power, so you get 3x plus 2 minus 2 over 3. So here you get 3x. 2 minus 2 cancelling each other. So you have 3x over 3. So we get x. Alright, so as a conclusion, we get both of this question, we get x. So we can say that n and m are inverses of each other because we use this definition, f or f inverse equals to x. Alright, so this is a graph of m and n. So m and n are inverses each other. So reflect on the y equals to x. So graph m and n are reflection on each other on the line y equal to x. So they are inverses of each other. Alright, this is homework for you. Try this and try to solve this question. Alright, see you next time. So bye bye.